Welcome everyone. Can everyone hear me? I hope you had a great conference so far. So my presentation will be about cross-platform mobile app development with Visual C++ 2015. First, a little bit about myself. I'm from Belgium. I'm a software architect working for Nikon. I'm a Microsoft MVP in Visual C++ since 2007 and also a Microsoft Extended Expert team member. I'm the author of Professional C++ 3rd edition and of C++ Standard Library Quick Reference. Both of the books are available in the university bookstore in the hall, so feel free to go take a look. And I'm also the founder of the Belgian C++ users group. We try to at least 3 or 4 times have a meeting about C++ in Belgium. This is an overview of the topics that I will cover today. So people that were here last year for CppCon 2015, they might remember my presentation on cross-platform mobile app development. This year's presentation is not a repeat of that one. Instead, it will build on top of the previous year's presentation. However, some people probably didn't see that presentation of last year, so I will give a quick overview of which topics that I mentioned last year. Then I will cover all the new features that have been added to the cross-platform mobile app story for Android, for iOS. I'll talk a little bit about game engine, and then I will end with best practices for cross-platform UI, where you have a platform-specific UI. So as you can see, there will be a lot of demos. Actually, I don't have that many slides, so let's hope all the demos work. And if you have any questions, feel free to interrupt me. So let's start with, yes? So those details, I'm not sure. You're correct that there is support for Linux, but yeah, this presentation will only cover mobile app development, so maybe we can talk about that offline. So let's start with my last year's presentation, a short overview. You can watch it on YouTube or on Channel 9, and what I discussed there was that a lot of the developers, they want to target multiple platforms because that means they have access to a bigger market share, and that means you can make more money. But developers don't want to do that if it is too hard to support multiple platforms. I also explained there are basically 2 ways to do cross-platform mobile app development. You have the silo approach, in which you use the dominant technology for your platform. So for Android, you will use Java. For Windows Phone, you will use C# or C++ CX. And for iOS, you will use Objective-C or Swift. Of course, those are 3 different languages, so that you have minimal code reuse. If you implement one feature in Java, you'll also have to implement it in C++ CX, in C#, Objective-C, Swift, and so on. So that makes the development cost much higher. And you also risk that one of the platforms will become the dominant platform. And with that, I mean that in the beginning, you might support all 3 platforms, but then you might notice that your Android application is giving you more money. And then new features you might implement first in Android, and then later you might port them to Windows Phone or to iOS, or you might not do that. In the case of the Windows Phone, you will probably not do that. And the second approach is to use a cross-platform framework like PhoneGap or Xamarin. The problem there is that you don't have fast iterations, so if you want to use new features of the latest SDK, you have to wait till that framework supports that new SDK. We also discussed last year what is actually the common denominator, and there is actually one. C++ is the common denominator on the 3 major platforms. So all 3 platforms, they support native C++. The benefits are, there are quite a few benefits of this. So you have the full native experience, you have full access to the device as long as the SDK supports it, but you don't have, if you want to use a new SDK, you can use it immediately. But code reuse is also much better. You can reuse your own C++ code, or you can reuse third-party C++ code. So you can just take the Boost C++ library, plug it in and start using it, or you can use the Unreal Engine or the Frostbite EA engine and so on. Performance, since it's running, since it's C++, it's running directly on the hardware, so it is performant. That also means that your battery life is better, because to get the job done, it's faster to get the job done, so you're using less battery. And with the security, I mean that if you have a compiled C++ code, it's much harder to deobfuscate your code. And so that's one of the reasons why around 75% last year, I didn't do the test again, 75% of the top 100 Android applications, they are using C++ in one way or another. So it might be they are completely written in C#, or they are using some native C++ library. I also gave a short overview of how you can do, how your cross-platform mobile app architecture might look like. So you see here that you have a big shared C++ backend, and then on top of it, you have a thin UI layer that is platform specific. For Windows, you will use XAML for your UI, and the code behind can be in C# or in C++CX. And if you're using C#, you will use pinvoke to connect it with the shared C++ backend. And if you use C++CX, you can just use C++ wrappers. For the Java, you're using XML. For Android, sorry, you're using XML and Java for your UI, and you connect it with C++ using, for example, GNI wrappers. And for iOS, you can use Cocoa Touch, and you use Objective-C wrappers. So this is the architecture that is used by quite a lot of applications like Bing Maps, Office, Skype, Facebook Moments, and so on. In the case of Office, for example, PowerPoint, I think, uses 95 or even more, 98% platform-independent shared C++ code with just a very thin layer. Then last year, we discussed the features of Visual Studio 2015 RTM. So it's an easy installation experience. You just need to download one installer, and it installs all the tools that you need. Otherwise, you would have to install different kind of compilers. You have to install Visual C++ compiler, Clang, GCC, and so on. You would need to install different build systems like Ant, Gradle, and so on. And if you use Visual Studio, it just installs everything for you. That also means you only need to learn one C++ IDE for all your cross-platform development, be it Windows, Android, iOS, and here I also mentioned Linux. Visual C++ makes it very easy to write shared C++ code and reuse it in your different projects, and I will show you how that works in one of the demos. Yeah, the state-of-the-art code editing features that you expect, like refactoring and IntelliSense and so on. Debugger of Visual C++ is rather powerful, and you can use it to debug on your real Android devices and on your real iOS devices. There is emulators that are shipped with Visual C++, Android emulators that is, and they are very fast. They run on top of Hyper-V. There are no iOS emulators because Apple does not allow that. And then there are a bunch of templates that you can use to start your cross-platform mobile app, and I will show a few of them later on. So what's new? That was the overview of last year's presentation. So let's get to the new content. Let's first start about, let's talk a little bit about Android. What's new for the Android experience? First, there is support for the latest Android NDK. It's R11C. And Visual Studio now supports 64-bit Android NDKs. And if you want to upgrade your NDK, it's now much easier. So if you have existing Android applications in Visual Studio, you can retarget them to use the latest NDK. Next, 2015 update 3 adds the Gradle build system. Gradle is actually the default Android build system, and it allows you to build Android artifacts like AARs and APKs. AARs are Android libraries, and APKs are the actual Android application packages. And Gradle makes it also very easy to reuse existing Android libraries, and I will show that with the Facebook Android SDK. Next, there is this thing called Java Language Services for Android, and this doesn't come out of the box, but you can download it from Visual Studio Gallery. I will also show you this later, but basically what it does is it adds a lot of support for Java files, so it adds colorization, semantic highlighting, support for squiggles, autocomplete, and so on. So I will show that later on. There is full support for debugging Java now in Visual C++ 2015 update 3. But one caveat here is that you have to switch your debugger to Java only. So you have to make a choice. You can either debug your native code or your Java code, but at the moment you cannot do any mixed debugging. I will also demo this later. If you download that package from Visual Studio Gallery, what you also get is an Eclipse Android project importer. So once that is installed, you can just do File New, Import Android Project from Eclipse. You select your Eclipse project, and then you mark which of the projects from Eclipse that you want to import into Visual C++. So those are basically most of the slides. So let's get into some of the demos. Okay. So if you go to File, New Project, then you will see that there is a bunch of cross-platform templates available once they appear. There we go. So you go to Visual C++, and then there is a bunch of cross-platform templates. For this first demo, I will show the Gradle build system. So if you go to Android, you see there are two Gradle templates, one to make a basic Android application using Gradle, and the other one to make an Android library. So let's start with a basic application. We give it a name. And now you see it's a very tiny template, so there is not much content here. But here you see this is a Java file. You see that you have the syntax coloring like you would expect. You have the squiggles. If you make a mistake, you will have a nice red squiggle. You have support for IntelliSense. Like here you get all the methods that I can apply to my text view. So what this application does, it basically just creates a simple text view, put some text in it, and then show it. Here you see your different platforms that are supported. So you have ARM 32-bit and 64-bit. And then you have the x86 and x64. So for this demo, I will use x64. And then here you see that those are the emulators that I talked about. So it fills in, it shows you all the emulators that are installed on your machine. And to manage that, you go to Tools and then Visual Studio Emulator for Android. And here basically you get a list of all the possible emulators that are available. For example, if you want to have a 10.1-inch Marshmallow tablet, you click just this download and install profile button. And what it then basically does, it will create you a Hyper-V virtual machine. Here are two of them. I have a KitKat Android and a Marshmallow Android. And so the list here shows you all the Hyper-V virtual machines that have been installed. So for this example, let's take the KitKat emulator. So if I build this project, you see here that Gradle is building everything. Since this is not doing too much, it shouldn't take too long. So in the meantime, when it's finished building, I will show you the debugging experience. So as I mentioned, you have to switch here to Java only, otherwise your Java breakpoints will not be hit. So let's put it to Java only, and let's put a breakpoint in my Java code. So here you see compilation succeeded. So now, if I run this in my emulator, then this is the emulator, which I already started before. If it hasn't been started yet, Visual Studio will automatically start your emulator, but then it takes a little bit longer. So I started it before already. So now you see that my breakpoint is hit. You have the logcat window here. Anyone that has done any Android development will know what this logcat is. It's basically your debug messages. And you can see that you have full support for inspecting your locals, the different threads, and so on. So you have the full Visual Studio debugging experience, debugging your virtual Android application. It also works with real devices, so I will show that later on. So if I continue here, then you should see that we have a nice Hello World application that was built using the Gradle build system. So I mentioned that with Gradle it's easy to use other third-party Android libraries, so let's demonstrate this. Basically, you have here your Gradle configuration file, which shows which configures things like the minimum SDK version that you target and so on, the platforms that your code supports. And here you have dependencies. And for example, if you would like to use the Facebook SDK, then basically you have to add one line. I'm not going to type it. I'm just going to copy paste it. So by adding this single line, you say that you're interested in the Facebook Android SDK version 4.7 or later. And now when you build this for the first time, the Gradle build system will automatically download this Facebook Android SDK and include it into your project. So since I already did this, it's not going to download anything, but it should compile. No, it doesn't compile. Yeah, it does want to download something, and I don't have internet here, so trust me, if you have an internet connection, this will download the latest Facebook Android SDK. And after that, you can simply do something like import. If it has downloaded it, then you will see that it will populate this list with the Facebook things. And then you can start using it. Okay, that's for Gradle. So yeah, what did I show? I showed you that you can edit Java code and of course C++ code, it's Visual C++, that you can debug your Java code, that you're using the Gradle build system, and that it's easy to incorporate third-party libraries if you have an internet connection. And thanks to the template, it's rather easy to get started. So it's just a couple of clicks and you're on your way. There is a very interesting resource on the Visual C++ blog if you're interested in getting to start Gradle. So here is the link. Next, let's take a look at what's new for iOS development. So update 3 makes it much easier to work both in Xcode and in Visual C++. So there are basically a couple of features to support this kind of workflow. The first one is that there is a wizard to import existing Xcode projects into Visual C++. I will demonstrate that. And then on the other hand, there is also in Visual C++, you can open an existing iOS project back into Xcode to make certain changes. For example, if you want to make UI changes, you will have to do that in Xcode. There is no support in Visual Studio yet for that. Similarly, if you want to modify your storyboard, you have to do that in Xcode. And if you want to sign your application for publishing it to the store, again, you have to do that in Xcode. And the open in Xcode makes this kind of workflows very easy. There is update 3 adds a much improved edit, build, and debug cycle, and it makes it much easier for discovering devices. So if you disconnect and connect devices to your Mac, it's much easier to discover those devices in Visual Studio. So just like as was the case last year, you still need a Mac for developing any iOS applications. So Apple legally does not allow anyone to cross-compile for iOS devices. In principle, it's not that hard. It's possible, but legally it's not allowed. So that's why Visual Studio always has to connect to a Mac to do the compilation. I will show that later. Now, just make sure I don't forget anything. So let's demonstrate the import from Xcode. I have here an Xcode project where you have your project pbx proj file. That's your Xcode project file. And it's this one that you can import in Visual C++. So let's do that. You go to New, Import, Import from Xcode. And then you get this nice little wizard. You browse to your Xcode project file. It's this one. And then basically most of the time you can just click next, 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 finished, import. But let's just take a look at what all the different windows show you. So here you see that it discovered 3 projects that it's going to import. And you see which files that it's going to import. And then there is also one native library inside my Xcode project, and you see I have here my C file and my header file. It's also going to import them. If you are using frameworks, you can add some search path here for that. Some more settings for frameworks, and then basically you just do import. That should make a Visual Studio project. There we go. So let's take a look at what the wizard has created for us. So here is a native lib.shared project. If I look under this, then you see my C code and my header file. So this is in a shared project. So basically that's not compiled on its own, but that's something that you reference from another project. And in this case, there is a native lib iOS library. If you go to properties, you see that this will generate a static library. There is no code directly into this project. The only thing it does, it references my native lib.shared project. And if I compile this, I have a static library containing my add_me function. Then next, I have here a sample native project. This is my actual iOS application. This generates my application, and you see this one references my static iOS library. Then you have here your Objective-C code, and if we take a look at my view controller, what I'm doing here is I'm including my header file, and then basically straight away I can use my code. And this complicated way is to show a message box. Here I'm not a big fan of Objective-C, but this is the way how you convert an integer to a string. Then I'm showing this in a message box. So, as I mentioned, you need a Mac to compile this, and to set up the connection between your Visual C++ and your Mac, you have to go to Tools Option, and then under Cross-Platform, there is an iOS pairing option. Here you have to specify the IP address or host name of your Mac. Then you just click the pair button, and if this is green, that means that you have a successful connection to your Mac. So I have here a VNC connection to my Mac OS, and on this machine you need to run something called VC Remote. Later on I will show you a blog post that explains you how to set up all of this. So you just have to run a couple of commands on your Mac and it installs VC Remote. And that the VC Remote is responsible for the communication between the Mac and Visual C++. So if I do the pairing again here, then you will see there something will appear in the VC Remote window. There we go. So let's switch to 64-bit and let's compile this. Then you will see that basically my Visual Studio project is now zipped. It's sent to my Mac, which extracts it. It's converted to an Xcode project and built on the Mac. All progress reporting messages and so on, errors and warnings and so on are marshaled from Xcode back to Visual Studio. So I'm just showing you this window now that you see that it's doing something, but basically if it's running on a server or you don't have any connection, that works fine. You see everything here in your output window. We see it succeeded, so that's good. Then here you have a bunch of emulators. This is a list of all the emulators that are installed on my Mac. So let's take the iPhone 6. And then if I take a look at my Mac, it should start an iPhone 6 emulator. There it goes. Takes a little while to start. So this is my application. And now if you remember, I have a button. When I click it, it will call my add_me shared function, and it will display it in a message box. So let's hope this works, and there we go. It shows you the sum of 20 plus 30. Okay, let's quit the simulator. So the next thing that I want to show is I would like to modify the UI a little bit. So as you see now, I just had one button. When I click it, displaying a message box. I would also like to see the result of my add_me call in a label underneath my button. So let's do that. As said, I cannot modify the UI in Visual C++, so I have to use the Open in Xcode feature. To do that, I simply click on my iOS application, and there is a menu called Remote Machine, and the first item is Open in Xcode. So what this does, it packages up your project, sends it to the Mac, and opens it in Xcode. It shows you a warning that once you're finished on the Mac side, then you have to synchronize the changes back to Visual Studio. You also see it here. It's marked, this project is marked as being opened in Xcode. So let's switch to the Mac. You see here, this is my Xcode that has been opened, and here you have the project. So for example, we can take a look at this launch screen.xib. This is my splash screen. I can modify this however I want. But for this demo, let's look at my storyboard. So this is my main UI. Let's add a label here. So you go to the navigators here. No, utilities, sorry. Object library. Let's search for a label. And we can just drag this label here. Now we have a label. Now we need somehow to connect this label up. Normally, you would go to View, Assistant Editor, and then you go to your header file, your View Controller header file, and basically now it's rather easy. You just click Control and you drag your label in between this add interface and add end. However, apparently VNC does not allow me to control and drag something, so I cannot demonstrate this. So let's do it then with code directly in Visual C++. So basically I'm finished here with Xcode, so I just close this project. I switch back to Visual Studio. As said, you need to synchronize everything back, so you right-click, Remote Machine, pull from Remote. It has downloaded everything back from the Mac, and it says that something has changed, so it's asking me to reload. So let's reload everything. There we go. Then what we have to do is we go to our storyboard. The storyboard is basically just an XML file, so I'm going to open it with an XML text editor. So wait, I think something went wrong. Let's try this again quickly. For some reason, it didn't save my label. Okay, utilities. Let's add my label. Let's save it. There we go. Now import the changes back into Visual Studio. Okay, here we have my label. So since the control dragging is not working in VNC, I'm just going to add the connection myself. But so normally you will not have to do this. Let's make sure the ID is correct. Oops. There we go. That's one thing, and the other thing is in your view controller header file, you have to add a line here to make the link. Again, this line and the XML changes are normally done automatically in Xcode. So now that I have this, now I can use my label and I can put some text in it. There we go. If I compile this, hopefully it compiles without any errors. What's this? I saw some red stuff, but maybe that's just the highlighter. Maybe I have an error here. I pasted on the wrong place. It has to be here. Yeah. There we go. 0 failed. So let's see if it works. Let's run it on my iPhone 6. Ignore that error. So normally my okay. Okay, so this one seems not to be working. I have to say something about the iOS integration. It's not very stable yet. Even though it's being shipped, it is not so stable at the moment. So they are aware of this and they are working on it. Okay, so that's it for the iOS demo. Okay. So next one, well, what I showed you is how you can import an existing Xcode project into Visual C++, how you can open a Visual C++ iOS project in Xcode, make your UI changes, import everything back into Visual Studio. And there are 2 resources here that are of great help if you want to start to use this iOS workflow. So next, game engines. Microsoft added a Jumpstart project for a game engine called Cocos2D X. This makes it easy to get started with this game engine in Visual C++. At the moment, it's only for Android, not yet for iOS. So let's demonstrate this. The first thing you have to do is yes, this is the page where you can download the Java language services for Android that I mentioned before. So for the Cocos2D X, you just go to their website and you download their SDK. For the Visual Studio Jumpstart project, you have to download the 3.2 version. So at the bottom here, you have looking for an older version. And then you download this one, the version 3.12, sorry. Once you have that, you unzip it wherever you want. I've done that here. And first you have to make sure that you have Python installed. And the next thing you do is you open a command prompt here. And you have to run this little setup script. It will ask you a bunch of questions, but you can all just use the default. You just enter a few times enter, and that's it. And then if this is the first time you did this, you have to close this console application and start it again. And then when you want to start a new project, you basically ask Cocos to create a new game project. You say that you want to use C++, and you say where you want to store your project. In this case, I'm just storing it in projects. I already did this. It takes a little bit, so I'm not going to do that here, but that's the syntax, how you get started with this. And once you run this Cocos executable, then if you go to projects, you have a my new game, and then you have your Jumpstart project. There is support for all kinds of different projects, but as you see, there is no Visual Studio there yet. So that's the Microsoft Jumpstart project that I mentioned. Basically, you download this file. I put the link in my slides. You download this from Microsoft and you just put it right next to the other projects here. And you just extract it. And then you will see there is a new project appearing for Visual Studio. And this project, there is a solution file which you can open. So there we go. So I'm going to start compiling it immediately because it takes a little bit. If I get control. Okay, that doesn't look good. Let's try this again. So I'm going to build an ARM version and not an x86 as I did before for my Android. Hopefully it works this time. Yeah, there we go. So I'm going to build ARM. Let's just start the build process. Why am I building an ARM? Because my emulators are x86. And although they are fast, they're running on Hyper-V, they are very fast emulators. They do not support the full OpenGL advanced features, and this game engine is using some advanced OpenGL features. So if you try to run this on your emulator, you will just get a black screen. There are some other commercial emulators available, maybe Genymotion that might work, but I didn't try that one. So for this demo, I will just use, it will be hard to see, but some people will see it. I'm having a real device here. So let's take while it's compiling, let's take a look at what the solution looks like. I have here a Cocos2D project, which is basically a Java project. This is my actual Android application. So it's an Android activity application, Java. And there is one reference just to a Cocos2D CPP library, and this is a native Android C++ dynamic library. You also see that here in the Java application you have some assets like fonts and PNG files, and these I can use from my C++ code. So if I take a look here, so this project is entirely C++, and this hello world scene file, this one is basically setting up my scene graph for my game. And you see I'm using here assets that are defined in my Android assets folder. So we see that everything compiled fine. So now I should be able to run this on my device. And if everything works great, then it should start showing something soon. Almost there, I have 3 big dots. So there we go. It's very small, but there is a small Cocos2D X logo. You probably don't see it from there, and it's running in Visual Studio, so I could put breakpoints here, and then I'm really debugging my real device here. So if you are using this, ignore this error. If you're using this Jumpstart project that I mentioned here, this zip file that you can download from a blog post that I will mention in my slides, one thing to take care of is that basically the only configuration that is working out of the box is debug ARM. The other configurations like debug x86 or release ARM, their project properties are not completely correct, so it will not build out of the box. So you might have to tweak those project properties a little bit by adding some extra include folders and some other settings. So if you want to start playing with this, just use debug ARM. So that's it for the game engine demo. So I basically mentioned everything what's on this slide. You saw this was also a combination about Java code. The main application is written in Java, and then you have the real code that is setting up your game and so on. It's written in pure C++. And in this case, the project was using the AND build system, not the Gradle build system. So you have a lot of flexibility here. This is the VC++ blog post that I mentioned. If you go to this blog post, there you will find the link to the Jumpstart project. Okay, so here is a small step-by-step guide what you have to do. You have to download that SDK, make sure Python is installed, run that setup script, create your new game, copy that Android targeting Visual Studio project next to the other project, unzip it, open it, and build it. At the moment, it's only available for version 3.12 of Cocos, but yeah, that might change in the future. Next, let's see a little bit how you do cross-platform mobile UI. So if you're making games, your game is probably full screen and you probably have custom UI. So then you can just use pure OpenGL, or you can use this Cocos2D X engine or the Unreal engine or any engine you want. And then it's rather easy to have the same UI on different platforms. For apps, it's a little bit more complicated. So if you want a custom UI for your app, then you can use the same mechanisms you use for games, or you can use something like Xamarin, which then you do your UI layer in C#, and then you have support for all the platforms available. Or you can have a C++ backend with a very thin platform-specific UI layer. So those are technologies I mentioned before on one of the slides. So let's take a look how we go about making this thin platform-specific UI layer in Visual C++. What I did for this demo, I started with this project that you can download from MSDN code. Just search for Hello GNI Android application sample. This one shows you how to use C++ from a native Java Android application. I started from this one and then added support for iOS and for Universal Windows programs. So let's take a look how that is done. So here we go. This is the shared C++ stuff that I want to share with all my different platforms. So in this case, I just have a simple function that returns me some C++ string. And here is the implementation. It just returns me a UTF-8 encoded string. So this is really pure native C++. Next step, I want to use this in an Android application, so I have to use this shared code inside a static library, an Android static library. You see there is a reference to my shared stuff. And then here I have a GNI wrapper that basically simply calls my C++ function and then converts my C++ stud string to a Java string. So that's all what this is doing. And then if I take a look at my Java application, in my Java code, I can simply call my string from GNI, and that one will call my C++ function, marshals the stud string to a Java string, and then I can do whatever I want with it in my Java code. So that's for the Android part. Next we have I added support for a Universal Windows application. I used, of course, a native C++ Universal Windows application. So it's using XAML for the UI and it's using C++CX for the code behind. And if I take a look at my main page, xaml.cpp, what I can do is I can just include my header and call my shared function and use it. This is a function to convert my stud string into a platform string. So it's very easy for the Universal Windows project. And then for the iOS, it's also rather easy if I take a look at my viewcontroller.m file. So this is Objective-C++. Here I'm calling my, again, I just include my header, and I can directly call my C++ function, which returns me a string, and then with this thing I can convert this into an Objective-C string. So let's take a look if all this works. So let's start with the Android application. Let's build this one. There we go. And let's set it as the default, of course. And then let's run it on my KitKat emulator. So hopefully I see something here. There we go. Of my breakpoint, let's disable this. So I have a native UI here, just a label. The content of that label is coming from native C++. And I have some text editor and I added some buttons, but so the UI is done completely in XML and Java. Next. Okay. Let's take a look at the Universal Windows project. Let's put this as the startup project and let's build it. It's already built before, so that's why it's so quick. For Windows Phone, there are also a bunch of emulators available, so I have one running here. So I can just deploy it to this emulator and run it. So this application uses XAML for the UI and C++ CX for the code behind. And you see it looks almost the same, but it's specific for Windows. So the buttons look like all the buttons on Windows Phone look. And my string, again, comes from my shared C++ backend code. Since this is a Universal Windows application, I can also run it on my desktop. There we go. So now I have an Android version running, a Windows Phone version running, and a Windows desktop version running. And then the last one is the iOS version. Let's build this. It's built before as well, and let's deploy it to my iOS. Let's hope it works this time. There we go. It's launching my. Take some time. There we go. So now basically we have a shared C++ code that is running on Android with a native Android UI. We are running on Windows Phone, we are running on the Windows desktop, and we are running on an iPhone. So I mentioned everything here. You have an Android-specific UI, an iOS-specific UI, and a Windows Universal App-specific UI. And I think that's it. I have some resources. You can go to the Visual C++ cross-platform mobile documentation. The link is there. There's a lot of interesting content on the Visual C++ blog. You can always contact me, and you can also contact Ankit Ashtana. He's the program manager for the cross-platform mobile development story. So that's it. If there are any questions, I have 5 minutes for questions. Yep.
Even if your native layer, your native UI comprises, let's say, 20% of the code, but when you have to write it from scratch on each platform, it adds as much work as developing the common code. Is there any hope of having multi-platform UI which somehow compiles into native stuff, like Qt?
So the question is if there is any framework coming for cross-platform UI, just develop it once. Well, you can use the Xamarin for that, as I think it was here. Yep. So you can use the Xamarin UI layer. Then you have to use C#, so it's not in C++. But then you make your UI once. You write it in Xamarin, in C#, and then it runs on all the available platforms. You can still combine this, the Xamarin UI layer, you can still combine it with native C++ code. Yep.
Excuse me, but there is also one UI layer that I know is cross-platform, but I don't think you've shown it, Qt. Can you put that Qt layer inside your C++ app and have your Qt manage your UI?
So the question is about, can we use Qt to manage the cross-platform UI? Most likely, but so my presentation is only about what Visual C++ provides out of the box. So I don't have experience with the Qt workflow. Yep.
Is there a tool to generate the JNI bindings, or do you just do that manually?
In this example, I did it manually. So the question is if there is a tool to make the GNI bindings automatically. In this case, I did it manually, but I think there is. I cannot remember the name.
Genie.
Sorry?
Genie.
Genie?
Yeah.
Okay.
From Dropbox has developed.
Okay. Yeah. So there is a tool that makes it easier. Yep. Yep.
Two-part comment and question. You do have out-of-the-box Java H, which will allow you to generate the headers from your native definitions for JNI. I don't actually recommend having auto-generated JNI because you can actually, any multi-threaded code, you'll have an immediate problem. My question was, is there any support in Visual Studio for debugging across the remote connection tiles?
Yes. Sure. Yeah. So the question is if you can use Visual Studio to debug either an remote iPhone, right? Or a remote device. Yes, that's definitely possible. So I always use Ctrl F5 now to run my demos. But if you just hit F5, it will set up a debug connection and you can put breakpoints and so on. Yeah.
And I imagine that only works for the C++ code. It wouldn't have the symbols for Objective-C, correct?
You can put breakpoints in Objective-C, yes. You can, yeah. I can see if I can get it to work. Where is my view controller? Let's put a breakpoint here. Let's run it. But as mentioned, iOS integration is not entirely stable yet, so that's why I always used Ctrl F5 for my demos. But it should work. So let's see. It's starting up here. So it always starts, even though there is already an iPhone emulator running, it starts a second one. No, wait, didn't break. No, it's not working, but it's supposed to work.
I'll take your word on the initializing debugger screen.
Yeah.
That's about the best I can do.
Okay. Yeah.
I just got a quick question. For the project you generate for, say, Android and iOS, can you then just load those into Xcode or into Android Studio directly, or does Visual Studio do some kind of mangling of things that it only really loads in Visual Studio?
So the question is what exactly happens when, well, if you can open a Visual Studio project directly in Android or Xcode.
Generated project is basically those platforms, is basically completely platform, or is it ends up kind of being dependent on Visual Studio?
No, it is. So if you do an open in Xcode, it really generates you an Xcode project, and so there is no support in Xcode to open Visual Studio project. Visual Studio will convert it to an Xcode project, and then you can open it in Xcode or save it or whatever you want.
The reason I'm asking is, some companies, I guess, not just ours, there'll be certain people who want to just use Android Studio.
Mm-hmm.
We've got a C++ developer doing C++ development targeting Android from Visual Studio.
Yeah, that I'm not sure. So there is support to import to open Android projects. You can just go file open Android project, but I'm not sure if in the other way it also works. Yeah, I'm not sure about that. Definitely for Xcode, because yeah, you always have to convert it back to Xcode because there you have to do the compilation. But for Android, I'm not sure. Yeah.
Xcode generated project, once it's been deployed on a Mac, can you then edit your native sources and then sync them back to Windows, Visual Studio? Or is it just for UI code?
I think you can do pretty much everything you want. Question is, why would you want to edit your native code on a Mac? If so, no, seems not. No, so it seems that my shared C++ code is not being transferred. No, so you keep using Visual Studio to edit that. So basically, you just use it to modify your storyboards, your UI, signing it when you want to publish it to the store, and so on. Yep.
I know you showed a couple logos of companies that are using C++ backend and then writing applications,
Yep.
mobile applications. But how many of those companies are actually using this technique where you're using Visual Studio to actually author the entire application process?
So the question is, if you look at those logos here, who of them are actually using this Visual C++ cross-platform mobile app workflow? That I don't know.
Yeah, I have a hard time. I would probably have a hard time convincing my hardcore iOS Objective-C developers to use Visual Studio and use Windows.
Yeah, well, if you want to target the other platforms, then maybe it makes it easier if you start using this workflow. So, yeah. Yep.
Is there any plan to add support for web applications?
Sorry?
Visual Studio. Is there any plan to add the support for web applications?
So the question is if there's any plan to support web applications. I'm not sure.
I think you can support Linux applications, but I don't think you can support web applications as of yet. I don't think there's really anything in the standard that allows you to support web applications.
You can make a makefile project that filled with theme scripts, and we do that.
Yeah. Yeah. So
Microsoft showed that you can page debugger to.
You can always start also use a web view. Use JavaScript.
yeah, can use JavaScript. Yeah.
Like for hybrid solutions.
Yeah.
That's even cheaper than writing and for every platform UI. So it's just one tool.
Yeah. Yeah. That's true. Yeah. Okay. Think time is up. Thank you.